Good afternoon to all. This is Rajiv Shivgaonkar this side, and we are into 10th episode of Wednesday Wisdom, and I'm very happy to be at the 10th event of this initiative which we have taken somewhere around 2 months back, and we have been getting a good response on these episodes. Of late, we have started inviting subject matter experts in this program, and it is our fourth such event where subject matter expert other than Nostar group is participating, and he is going to share his uh, uh, knowledge and on the topic of mineral and mineral oil transformer oil, which is we know in our day-to-day language. So before we go into the program, let me take you through a brief introduction about our company, Nostar. Nostar is basically active into three, four different areas, and which is number one is our consulting activities, which we are doing in different areas related to transformer manufacturing per se, as well as business process related like improvement of deliveries or inventory control, or for that matter productivity measurement. Plant capacity is a big challenge, especially when we are into a product which is engineered to order like transformer. So utilization of the plant is a always an issue, and we support our clients in increasing the utilization of the factory, and also asset acquisitions, different kind of equipment, right from VPD, VDP to winding machines, and ergonomic based, safety based design of transfer factories also we undertake. Other than that, we are into also design and cost of optimization of transformers. We have our experts and who help our clients in this area. Then our second activity is a typical field service, or we can say customer complaint addressal, where we take up right from erection, testing, commissioning up to spares, provision of different spares, starting from OIP bushings to your porcelains, gaskets, CTs, instruments, protection devices, and also insulating oils, that too natural ester, synthetic ester, and mineral oil. Then we are into preventive maintenance, that also, which is called retrofilling now, is something which is coming up in a big way, where the old transformers can be revitalized by replacing their insulating liquid by ester, from mineral oil to ester oil. That way, you enhance the life of the transformer around another 5 to 10 years, depending upon the transformer condition. We do that tech activities, and then we are into annual maintenance contracts, and we also help our clients in doing diagnosis of various issues which they are facing on a site at their transformation. Then our third activity is we are engaged with three companies. Savita is oldest among them, and Botwane and Streamer Electric. Streamer Electric is a Switzerland-based solution providing company where they have very unique products and services, like fire prevention, which is based on signal gas technology, where the detection of the hot joint or the poor joints in a panel is detected well in advance, before the stage of actual fire or smoking comes. So by employing this solution, you can literally make any chance of occurring fire in the panels by using this. Then we have online moisture management, that is also from Streamer Electric, where there is no need to shut down the transformer and take it for the offline filtration, where days and months together pass on and the transformer is out of the service. So with this solution, that thing is eliminated, and that way you save valuable productive hours, and also you enhance the transformer quality. Then we have lightning protection of overhead lines, and from what one we have online monitoring of transformer performance, where basically you are converting your transformer into a smart device. You are putting this solution on your transformers. With that, lot of data which is transformer is generating will be available on your smart devices. So that way your transformers are accessible to you 24 hours, 7 days, 365 days on your devices. And by looking at the screen, you can identify what is happening to which transformer and what need to be done. And then, of course, we are with the Savita polymers in K-class insulating liquid, where we support them in educating the transformer manufacturers and also supporting them some aspect of the transformer design as far as the K-class insulating liquids are concerned. Then our fourth activity is this activity which we are doing today. It is a knowledge share activity where we have North Star Knowledge Academy, and we have different programs related starting from product design, also shop, up to shop management. Also, we have special experts on welding technology, bending technology, as well as fabrication and quality assurance, operations management, and in a big umbrella that is improvement management also. And we conduct these workshops on time to time in physical physical atmosphere that is to be used nowadays after the onset of corona. So we do conduct physical programs where people can come physically and attend the programs. That was till very beginning of the lockdown. During lockdown, we have switched over to this webinar model, and we have devised this 90-minute module on every week where we uh, select different topics and uh, invite the guest and share the information. So this way we are doing this knowledge sharing as our fourth activity. So under this umbrella, we are today having Dr. Milind Vaidya in our forum, where he is going to talk about journey of the mineral oils right from the beginning to the today's situation and what is going to happen in future. He is Chief Technology Officer of Savita Oil Technologies Ltd, and having a vast experience of more than 23 years, in which last 15 years he has been in top leadership roles, including global assignments and positions. So he has been working with different industries like specialty chemicals, polymers, downstream carbon chains, etc. And also, very importantly, that he is holding 3 global patents, and he has been instrumental in developing various new products over the span of his career. Apart from the career, he is passionate about science, and he loves playing badminton and swimming, and he also loves reading. So with this, I'll be inviting Dr. Milind to the program. I will be disconnecting this screen, and I will request him to connect his sheet over here. Dr. Milind, welcome, and
Thank,
you can start your
yeah,
presentation. Thank you
thanks for
so
the
much.
kind words, Rajuji. 1 second, I'm just let me.
You're mute, Dr. Milind.
Can you hear me? No, I'm not on mute. Can you hear me?
No, your voice is not audible.
Yes, sir.
Can you hear me now?
Yes, you are here.
Okay.
As Dr. Milind is switching on, just a small piece of information. You can put your questions in the chat box, and we'll be taking up those questions once Mr. Dr. Milind's program is over. And also, Dr. Milind will be supported by Mr. Girish. He's a DGM with Savita Oil Technologies, with having an experience of more than 20 years, and he also will be sharing a good deal of information in the program. Dr. Milind, over to you.
Thank you very much, Rajivji. So good evening, everybody, and it's my honor, privilege, and great fun to.
I'm not getting your.
Can you hear me?
Yeah.
Yes.
Yeah. It's an honor, privilege, and actually fun to be part of this particular forum. It's my passion to teach, and that is because of a very selfish reason. The selfish reason is that it is said that if you want to learn, the best way to learn is through teaching or through sharing your knowledge. So I take this as an opportunity to tell and give some amount of what I know, but more importantly, to hear from you in the end around questions, and if there is anything that I am not able to answer. I can only promise that we will get back to you with the answers that we find. And in the process, we all will learn and we will continue in our journey towards continuous improvement. One thing which I should have said or at the beginning is also that I'm a big Bollywood buff. So I love Bollywood. If you are in love with Bollywood, you cannot ignore the Kapoors. So I thought when Rajiv came to me and asked me what theme would you like to speak about, it took me only 1 second to come back and say that I will talk about mineral oils, Kal, Aaj or Kal. So basically, as the name suggests, we will be talking about the journey of how the transformer oil industry has evolved over the years, and especially talking about what we have been doing in the past, which is Kal, what is relevant today, which is the Aaj, but more importantly, what will remain relevant in the future, and how the oil industry, especially specifically the transformer oil industry, will move towards continue doing a lot of the same, but also move towards newer products. So that's the theme of my presentation: transformer oil journey, Kal, Aaj or Kal. So let's begin. I'm sure this is something that people in the forum actually know about it more than I do. I am a chemist, not an electrical engineer, and hence my sort of field area is limited to the molecule structures, how to make, break, and decipher chemical reactions. But the role of oil in transformer is essentially cooling. So it cools it dissipates the heat that is generated because of the transformer action. It insulates, so obviously it provides an insulating material between the electrodes. But also sometimes we miss out the fact that it also acts as a diagnostic tool. By doing the oil monitoring, it is a great tool to understand how the health of your transformer is, and we will come to it subsequently as part of the presentation. Lot of information, and this information is very valuable, is obtained when we do analytical data of the oil in process. Specifically, we will talk a little bit more in detail about the dissolved gas analysis, that is DGA, and what data can be interpreted around the health of the oil because of the analysis done by DGA. Last but not the least, the role of an oil in transformer is to protect the solid insulations like the paper and things like that. Now, very important. Why are these oils called mineral oils? The answer is very simple. It's in the name itself. The first oil that was found among the minerals. These oils are actually available to nature after millions and millions of years. This is why they are called non-renewable. It is said, मिट्टी से आए और मिट्टी में मिल जाएंगे हम. The same way, हम मिट्टी में मिलने के बाद million year के बाद we will become oil. So what oil we see today is because of the dead fossils or dead bodies which have decayed and under a lot of pressure in the earth's surface, under the earth's surface, to become carbon, and then becoming from carbon to hydrocarbon and hydrocarbon to oil. So this is a typical oil cycle that you see in the slide on the left hand side, where the dead bodies keep decaying. That dead bodies can be of animals as well as plants, and that is the only source of carbon that is available to us. And over years, it becomes into oil. It gets converted into oil, and then from below the surface, the first step to get towards getting oil is to bring it to the surface. So that below the surface can be on land. That's how it all started. The first oil was discovered on land, but today sea is a very big source of oil. When we hear the word deep sea exploration, typically it means समुद्र के नीचे से पानी निकालना, which means that we actually look below the surface of land under the sea to bring out the oil. Just imagine how difficult it would be to drill such deep into the ocean's floor and remove the oil. We hear about the KG basin, Krishna Godavari basin in the Bay of Bengal. In India, that is a very rich source of natural gas and to a certain extent some amount of crude. How does it look like? Crude are classified under various categories: sweet, sour, light, medium, heavy, very heavy. Sweet means it has lower amount of sulfur in it. Sulfur is something which you don't want. So sweet oil means it has lower amount of sulfur. Sour oil means it has higher amount of sulfur. Medium, light and heavy is very easy to understand. This here is light oil. This here, although it is called heavy, it is medium or heavy, and these are very, very heavy. The lighter the oil or lighter the crude composition here, better it is or easier it is to refine. Also, for a refinery, one thing very important to note is the source of oil is very important. If a refinery is equipped to handle only sweet kind of the crude source, then it will not be able to refine the sour source, because it will create corrosion into the refinery and the refinery will be damaged. Hence, it is very important while designing a refinery to make sure that you are able to have the flexibility of handling both sweet and sour kind of crudes. A refinery at Jamnagar from Reliance was one of the first refinery that was able to handle both sweet and sour type of crudes. So let's look at Kal, as in yesterday, how it all started, how the oil started coming in, how did we start getting the oil. When you take out oil from the ground, you first need to refine it. And we will come to that in a certain, in a couple of slides from here, wherein you get what is called, you do a process that is called as distillation. By distilling it, we get different cuts: gas, light, medium, heavy, very heavy, and bottoms. That's how the fractions of the cut are collected. One such cut is called as the base oil cut or the mineral oil cut. Depending upon the industry that you are in, the names vary a bit, but it is the same thing. So a base oil cut or a mineral oil cut is then taken and it has to be purified. Earlier days, the method of purification that was employed was called as solvent refining. So first you have already refined. Let's take one step back. You already refined it. On refining, you have already got a specific cut from the crude of base oil. That base oil is purified by another set of refining, which is called as solvent refining. What does solvent refining do? All impurities, it is removed through the solvent. But there are issues because solvent is not environmentally friendly. Hence, you are actually polluting the environment. But not only that, by doing solvent recycling, you are also increasing the cost, one, and two, you need to make sure that you recycle the solvent. You cannot use a solvent and throw it. You have to keep on reusing the solvent. So it adds another step to the refining process. Now, a typical mineral oil composed of several types of molecules called paraffins, as you can see over here, isoparaffins, which is over here. I'm trying to adjust my screen 1 second, so that isoparaffins are over here, cycloparaffins and aromatics. Now, N stands for normal. Normal paraffin means they are straight chain molecules. As you can see over here, they are straight chain. Isoparaffins means they have branching in it. And each type of molecule has a particular role in terms of a particular property. Cycloparaffins are cyclical in nature, circular, whereas aromatics are cyclical but also have double bond and what is called as aromaticity. There are also sulfur based compounds, as you can see over here, which are present. Now some molecules are good. So N-paraffin, isoparaffin, even to a certain extent, some amount of cycloparaffin is good to have in your product, but there are certain molecules which are bad. What solvent refining does is removes the bad molecules. So it removes the aromatics and PCAs, which are polycyclic aromatics. It also removes sulfur-based molecules, and it also removes some amount of residual unsaturation. It does not remove all unsaturation, but it removes some amount of residual unsaturation. So essentially, by doing the solvent refining step, you are removing the bad from the mixture, and you are getting finished mineral oil. But that is skull. What is happening today? So there are two steps. First, what you have done is you have removed the bad. But after removing the bad, you can also make the good into better. How do you do that? That is what is being done today in terms of modern refineries. The first step towards that is called as hydroprocessed. Hydroprocessing means hydro, as the name suggests. Here hydro does not mean water, it means hydrogen. So hydrogen gas is passed under very, very high pressure and in presence of specific designed catalysts to convert the unsaturation. Remove is not the right word, actually it converts the unsaturation, which is a double bond, into a single bond. So by doing the process is called as hydrogenation. So by doing hydrogenation, we are actually converting the bad molecule into a good molecule into a better molecule. By removing that, what we are doing is we are improving the oxidation stability and also improving the color. The light yellow color that you see in an oil means that there is an unsaturation. Pure white oil means that the unsaturation has been removed or it has been converted into saturation. The final process is called as hydrocracking. Typically, when you have an oil, the range of molecular weight distribution is very large. And to have consistent uniform property, it is better or best to have a very narrow molecular weight distribution. To do that, we actually break down larger molecules and reform them into similar molecules. That is called hydrocracking. That process is also done in presence of hydrogen, wherein, as the name suggests, hydro means hydrogen and cracking means breaking of molecules. Sorry. So you break the molecules because of hydrogen under high pressure and then you reform them into similar molecules. This further improves the oxidation stability, makes the molecular weight distribution very narrow, and it also improves the flow of the oil. So essentially, sometimes you are also reducing the viscosity of the oil by doing this process. So something about what we talked about just now, cyclics. When you are doing hydrocracking, you have cyclic molecules which get converted into paraffins. You have opened the chain from a cyclical structure, which is circular type, closed structure. You have made it into an open chain. Aromatics, you have first converted aromatic into a non-aromatic. You have removed the double bond and then the cyclical structure is made into paraffin. Long chains, like I said earlier, are cut and made into smaller chains to give you a lower viscosity and a better molecular weight distribution. Same way, hydrofinishing. Here you can see the double bonds. These are called as double bonds. These double bonds are converted into single bonds. So this is how the process looked like. I told you about the cuts. So if you consider this as a one single large distillation column, here is where natural gas comes out from the top. And then as you go down, it starts with lower naphtha to petrol to diesel to, this is the cut of the mineral oil. Again, mineral oil, group 1 is solvent refined. From group 1 to group 2. Can I ask somebody who is not speaking to go on mute? So group 1 is solvent refined. Thank you. Group 1 is solvent refined. From solvent refining, if you do hydroprocessing, it is group 2. And from solvent refining, if you go into severely hydrocracked and catalytic dewaxing, wherein the wax is removed, it is called as a group 3 type of base oil. So what is the transformer oil made up of? We already discussed this. I'm just trying to rephrase it in terms of the analogy that people in the industry understand. It is mixture of paraffinic, CP, naphthenic and aromatic molecules. CN are naphthenic and CA is called as an aromatic molecules. And they are available in different ratios. Depending upon the ratios and the proportion, they can be classified into paraffinic or naphthenic type of base oils. There are some subtle differences between properties between paraffinic and naphthenic. Pour point is one. Pour point of paraffinic is more than naphthenic, so naphthenics have lower because of their cyclic structure. They have a lower pour point, so they are able to flow better. But oxidation stability of paraffinic is much better than naphthenic. So typically, because of higher temperature in tropical countries, paraffinic have better sort of sustainability in the transformer because of higher oxidation stability. And at similar molecular weight, naphthenic has got lower viscosity, and hence it can potentially give slightly better cooling because of that change in viscosity. These are some of the terms that you would be encountering in your daily discussions, which are called what I would term as broad classification of mineral oils. They can be classified into uninhibited, means it is pure mineral oil without any antioxidant. We must have all heard about antioxidant. Even today, if you look at the cosmetic industry, they keep talking about various sunscreens with antioxidant. There are medicines which claim to have antioxidant property, and there are mineral oils that also have antioxidant properties. Now, what does an antioxidant do? As the name suggests, anti means opposite, oxidant is for oxidation. So it is the opposite, it does opposite of oxidation. Basically, it prevents oxidation. Oxidation, as we all know, is harmful to us. Vitamin E is a well-known natural antioxidant. Same way, mineral oils have their own antioxidants, and we will look at one of them, which is the most popular, subsequently. But basically, uninhibited means a mineral oil which does not have an antioxidant. Trace inhibited means mineral oil with trace amount of very little amount of antioxidant. And inhibited means mineral oil with recommended dosage of antioxidant, which are the typical inhibited type of mineral oils. We already talked what is an antioxidant. It means it prevents the degradation or the oxidation of oil. And we will look at in subsequent slide, we will look at how it acts. It acts by quenching a free radical that initiates degradation, but we will come to that in a later slide. This is the slide that I was talking about. Let's take the most popular antioxidant that is used in mineral oils, and the one which has already been approved. It is called as a butylated hydroxytoluene. So what actually it does, this OH group with a cyclical benzene ring is called as phenol. These two are the tertiary butyl, and because it has a methyl group, it is called toluene. So butylated, so tertiary butyl 2,6-ditertiary butyl hydroxy OH toluene, or it is also called in common language hindered phenol. This is a phenol which is hindered, which is prevented actually by two large arms around it to have more contact. What it does is oxidation starts with free radicals. So if there is an unsaturation in a mineral oil, or if there are what is called as beta hydrogen atoms, they are susceptible to oxidation. So by oxidation, what it means is it generates a free radical in the chain of the mineral oil. Now, when that free radical is generated, it can actually start propagating. To prevent that propagation and hence to stop oxidation, the antioxidant BHT, butylated hydroxytoluene, or ditertiary butyl phenol, actually gives out their hydrogen and takes away that free radical that is formed in mineral oil. This is called as quenching. So by quenching that free radical, it prevents further propagation of oxidation in the mineral oil chain. This is how an antioxidant works. If you are not a chemist, there might be some difficulty in understanding this, but in terms of a simple man's language, an antioxidant prevents oxidation by quenching the free radicals that are formed on the backbone of the mineral oil chain. So we talked about Kal and Aj. So we talked about how mineral oil were there earlier, how mineral oils are there today. Now let's try and see into the future and how mineral oils could potentially look like tomorrow. So yes, mineral oil were good today, were good yesterday, are good today, and to a certain extent will definitely continue to remain good tomorrow. Let us be very honest, over a period of time, the quality of mineral oil has improved. As we saw solvent refining, we talked about hydro processing, we talked about hydro cracking. So by doing all that, over the years, the property and the benefits from mineral oil have improved. There is no doubt about it. But in spite of that, there will be certain limitations to a mineral oil. Those limitations are lower flash point. Their flash points are quite low compared to the options that are now available. They are not biodegradable. They have extremely low biodegradability, which means if it gets damaged and leaks into the environment, especially when the environment around them is quite sensitive. So if you are having transformers near the sea or near marsh or near sensitive areas, then the leakage, if it happens, would remain into the sand or the earth or the water for a very, very long period of time, and hence it is not desirable. And it has very low tolerance to moisture. A little amount of moisture at your breakdown voltage would go haywire. Whereas now options are available that are based on either natural esters, which is from Savita Oil perspective, biotransol, and synthetic ester based transformer oil, which is transol synth from Savita Oil. So now options are available which would take care of some of the limitations of a mineral oil. Let's look very quickly into a single slide of natural ester. Natural ester based product, essentially, like I was telling you, biotransol that we provide, it has got a very, very high biodegradability. That means if it gets into the environment, it could be easily biodegraded into very, very small molecules, and they will not cause damage to your environment. It has a very high flash point. Now this, because of this high flash point and a very high fire point, it can now be classified under class K. By classifying your transformer and the entire thing into class K, the insurance premiums that you need to pay would go down. So that is a very big advantage, not only in terms of providing the assurance and the safety that a high flash point gives, but also in terms of a long-term cost benefit, because insurance premiums are recurring cost. So that if that is reduced, it keeps on getting, you keep on getting the advantage of the lower cost for a longer period of time. They also have very good moisture tolerances, and we have actually published papers and published papers and presented it in leading forums around how, because of this high moisture tolerance, the benefit are obtained. We can get a reasonably good lower pour point of up to minus 21 degrees centigrade, even up to, we have a grade to up to minus 30 plus type of 30-31 type of pour point. But the limitation here of natural ester, let's be clear, is that it cannot be used for breathable transformers. So what it means is that because then you have to have a particular type of transformer only that can use biotransol or a natural ester based product. Let's look at the salient features of a synthetic ester based product. It also has a good biodegradability. And like natural ester based product, it also has a high flash point. Same way, it gets classified under class K, lower insurance premium every year. So that's a recurring cost saving that we can get if you are using synthetic ester. It has also got a very good moisture tolerance. The pour point here is very good. The pour point here is up to minus 54 degrees centigrade. So you can use it under extremely cold conditions. So, the synthetic ester, transoxin. Very, very strong oxidative strength. It is fully saturated, which means it is high susceptible, it is high resistant to oxidation, and it has got a very strong oxidative strength. Last but not the least, it can be used for seed as well as for breathable transformers. Since we said earlier in the previous bullet point that it has a very good oxidative strength, this gets converted into the fine application base where it can be used for all types of transformers. I will take a pause here and I would now request my colleague Girish to take us through the rest of the slides, wherein we will be talking about correlating the property with the transformer requirement. Girish, can you take over the slides? Girish, you are on mute. Yeah.
Hi everyone, this is Girish Morde here. First of all, I take this opportunity to thank Vaidya sir to making me the part of this presentation. So he has covered a lot of things about the mineral oils from hundreds of the 150 years past till date today, and what is the future of mineral oil as well as the what are the futuristic and realistic oils for the transformer oils. So let us now restrict, as the topic suggests, that it is of mineral oils related chemical properties and its physicochemical properties as well as electrical properties and their importance in terms of how one can relate these properties of oils, fresh as well as used oils, with respect to the quality of the transformer or the life of transformer. Next slide. So in terms of physicochemical properties, oil, when you take a fresh oil, there are the 6 to 7 properties. One has to keep a flash on that. That is a viscosity, pour point, oxidation stability, moisture, free acidity, flash and fire point, and as well as the IF. As you know, these all properties, when you take a fresh oil, there are the certain specification as per IS 335 or certain international specifications. You'll have to give the oils in terms of their limited values, maximum or minimum, you can say, which are given in the standards. We'll touch each and every property and how its increase or decrease, or the value, suppose it goes somewhat above the specification or below specification, how it is going to impact the electrical behavior of the transformer or the performance of the transformer, one can in short say. So next slide. So for in terms of electrical properties, breakdown voltage, everybody I think from the electrical transformer industry, so they knows all these three properties. The breakdown voltage and resistance of the insulation, oil resistance, you can say. Then third one is a dissipation factor, that is, you can say in normal commercial language or people language, that is a power factor. So we'll touch that also. Next one. So as I briefly touched in my earlier slide, how it is going to impact the properties, these oil properties. First of all, before starting this thing, I would like to say that in the transformer, apart from the Vaidya sir word, I would like to add up one of the most important sentence, that is, the oil is the only component in the transformer which touches each and every part or every component of the transformer. So it takes whatever is happening in each and every corner of the transformer to it. Whatever is forming, suppose heat is forming, oil is taking the heat. If it doesn't allow current to flow from apart from the coil, say primary to primary to secondary load, it doesn't allow us to touch to the tank of the oil. So which is the purpose of the oil? That is insulation. So let us again come back to our properties section, that is viscosity of the oil. Lower, everybody knows the viscosity of oil is low. Lower the viscosity, the conduction of the heat, which is a primary function of the oil, that is to cool the oil. So it will take that heat from cooling from oil to the fins of the transformer. There it will dissipate, that heat is dissipated from the fins to the air because of the forced circulation or the natural circulation of the air. Again, there are always there is a generation of the hot spots. So hot spots in the transformer, there is always a high temperature. So this oil takes away the hotspot temperature or the heat generated at the local hotspot, and it take away and it dissipates throughout the oil as quickly as possible if the viscosity of the oil is low. So it prevents further generation or further increase of the temperature. Second physicochemical property, that is a pour point. In terms of pour point, this property is for the countries like India, it is not much importance, but the countries like very cold countries like Europe or you say Antarctica or Canada, where this pour point properties matters, because when basically in terms of pour points, the most important thing is the cold flow property of the oil. Say near pour point, what is the viscosity of the oil, how it at what temperature it gels, because if suppose oil gels at a say in the early temperatures and the pour point is somewhat low, so you will have to have the certain cold start procedures for this oil to run this transformer, and this will be the most important thing when you take a shutdown of the transformer and going to restart of the transformer. If pour point is not good, so you will have the certain problems, so you have to give certain heating arrangements. Now we'll turn to the moisture. The moisture of the oil, see, everybody is saying that the mineral oil moisture limit is something around 30, 35 or 40 ppm, not more than that. Because this is just because of the low moisture saturation points of the mineral oil. And again, the moisture is most harmful molecule which impacts most of the property of the transformer. Say electrical properties. When moisture is high, your breakdown voltages will come down. It is going to impact the quality of the oil. It is going to deteriorate the paper because the oil itself, mineral oil itself, are somewhat hydrophobic, or you can say completely hydrophobic. So they don't keep moisture with them. As soon as there is a larger amount of the moisture, it will dissipate to the paper, and the quality of the paper is going to hamper because of this moisture and the high temperature. That is our transformer running temperature something around 82, 85, 90 degrees Celsius, or somewhat sometimes 80 degrees Celsius. Now, there is a next property is a free acidity. In case of free acidity, you know, just earlier I had talked about the moisture. So the moisture is also responsible to generate the free acidity in the oil. So because of the moisture and temperature, there is always a reaction taking place with the oil, and there is a generation of the, as sir in earlier slide said, there is a formation of free radicals. So it is, I'm going somewhat chemistry point of view, that is there is a formation of initial hydroperoxides, then peroxide, and then acids. And these acid molecules are free radicals which can initiate the process for generation of further acid molecules, as well as it is going to hamper the quality of the paper, which ultimately hamper the life of the transformer, because everybody in the transformer industry says one sentence, the life of the transformer. The life of the paper is the life of the transformer. Next slide. Now we'll come to somewhat other properties, that is a flash point. Of course, flash point and the fire point, two are interrelated properties. There are the two different flash point generally transformer industry makes. One is a closed cup flash points and the other is an open cup flash. The basic difference between the two flash point is nothing, that one is measured at a closed conditions where the vapors are kept in a closed conditions, and other is an open type of transformer. And basic difference between flash point and fire point is in a flash point you will have to provide the external fire source. Whereas in fire point and more than a fire point, you will have to have the same thing but in open cases. And these properties are the most important thing because you should not have the lower flash point because operating conditions of the transformer are something around 80-90 degrees Celsius as well as the hotspot temperatures of the transformer sometimes goes near flash point or most of the times above flash point also. So in those cases, if you choose the appropriate flash point, so the flash point mentioned in the specifications or well above the specification, it will be always better for the manufacturer to have the certain cushions on these things. Now, apart from this, there is one people generally use this IFT, that is interfacial tension. Basically, interfacial tension is a surface tension between the two different bodies, say water and oil. So, which is basically, I'm not going to deep chemical terms in this, but the one has to understand what does it give. Basically, interfacial tension gives basically your what is the, if your IFT is low, then which is an indication that there are the polar impurities present in the oil. And if your IFT is high, then you can say that the oil has a very low or very low polar impurities. Basically, polar impurities, the importance of the polar impurities because these polar impurities are going to hamper drastically to your electrical properties of the transformers. That's why one has to always keep an eye on a IFT, interfacial tension of the oil. Next slide. Now we'll look at the certain electrical properties of the oil. So I think everybody now will understand more thoroughly about those things. That is basically electrical properties and dielectric dissipation factor. Basically, this measures the tan delta or a loss factor, or somebody says it is a power factor. So the high DD, if you consider the high DDF, there is a leading to the thermal run. That means there will be always increase in the temperature because of the certain corrosion and oxidation. There will be formation of certain polar impurities, and your dielectric dissipation factor is going to affect. This dielectric dissipation factor sometimes affected by your soluble water. Suppose there is a water soluble solubility is there, or certain emulsifiers when they interpret it comes to the oil because of your certain paints and those all things which are used to seal the edges of the metals you are using, or inside tank you are using some resinous material to have the tank strength and those all things, or from the corrugated papers or those things, or a wood, pressboard wood. Suppose there are certain emulsifiers which may come to them, they are going to affect your dielectric dissipation factor or loss factor. So low DDF means there is a low moisture, there is a low polar component. Basically, these polar components, earlier in my sentence I told you all these impurities are soluble, or in terms of insoluble impurities also you will have these things. Lower the DDF, there will be always lower power losses. That is everybody is clear here now. Next slide. So basically, test for in-service transformer I'm talking. So there are the various tests which I had just discussed, that is a dielectric dissipation factor, breakdown voltages. These are particularly electrical tests which are important. Apart from that, these are the other tests one has to conduct, that is a furan derivatives, furan and its derivative. Now, where from the furan comes? If you take the fresh oils, you will not find the furans. Basically, furan is a chemical or is a molecule which is formed from the degradation of the paper. Degradation of the cellulose in presence of moisture and in presence of the temperature will lead to formation of these furan molecules. So what happens, when oil has a certain moisture which above saturation level, these mineral oils will tend, these papers are hygroscopic because of the cellulose natures. That papers will absorb the moisture or take up moisture. In simple language, I will say they will take up the moisture from the oil and take it into inside this cellulose molecules. At the high temperature, moisture and cellulose will react, and the cellulose molecule will break and it will form the furan. And this furan from the paper will go to the oil. And because of this, impart of the furan from the paper to the oil on aged oil will show there in the furan content. So from that furan content, one can guess or one can interpret what will be the futuristic life of the transformer. When you have the certain data on the furan content, periodic data, say after 1 month, after 2 months, or after 6 months, or after 1 year, this much is a rise. And plotting of those graphs, one can determine the degree of polymerization of the paper, and that degree of polymerization can be converted into the life of the transformer. So normally what happens when you take the new papers, the degree of polymerization is something around 1200, 1250. But whenever there is a aging of the paper, it takes the degree of polymerization reduces from the 1200 to least say around 200, 250. Normally transformer oil industry, everybody knows when it goes below 250 or something, you will have to consider that the paper is now fully degraded and you have to go for the replacement of the transformer or think for the certain remedies other than that. So metal content of the oil, which can be see by the metal content, there is a corrosion of the copper or corrosion of the other parts. This metal comes to the oil. They might be insoluble, they might be soluble form, but soluble or very low solubility, that is the form. So one has to have the visual inspection of the oil, periodic visual inspection, have the strict eye on that. What is the color of the oil? Basically. So more darker the color, that indicate there is an indication of the oil is contaminated by the soluble impurities like metallic salts and those all things. Moisture content. Whenever you take the sample of the in-service transformer, we have to measure the moisture. The increase of the moisture suggests that there is a leakage in the transformer somewhere in case of the non-breathable transformer. So these leakages one can attend and restrict this moisture, because whatever increase in the moisture is going to hamper the quality of the paper periodically, and ultimately it is going to reduce the life of the transformer. Next slide. So as sir said in early slides that in-service transformer dissolved gas analysis is one of the important tools. I am just briefly touching this. There are when you consider the dissolved gases, there are basically the two dissolved gases. One is the spray gases and other are the fall gases. Spray gases, basically the gases naturally dissolve in the oil from the atmosphere, or fall gases, basically when there are the hotspots generation. You know everybody that there are the hotspot generation of the near to the coil, and because of the hotspot generation there is a very high temperature rise point is there. At that certain point there is a very high temperature, and the molecules which are coming in contact with that high temperature sometimes degrades, and these gases will produce. So these gases are a fault gases. So majorly when you do the DG analysis, you have to keep the eye on this methane, hydrogen generation, acetylene generation. In case of the transformer, the acetylene and ethylene are the most, when there is increase, then the situations are alarming. You have to look into that, and you have to attend why it is happening. You have to really resolve those things, from where these gases are generating, where are the hotspots, and you have to attend those things. Next slide. So maintenance of I am touching somewhat maintenance. I hope everybody, those who are transformer managers, they have these maintenance procedures, as well as the oil handling procedures. These all procedures will be there when they are buying the oils from anybody from the Savita or anybody. They are buying the oil. They always provide the procedure for the oil handling as well as transformer manufacturers, they use the maintenance procedure. The oil level of the transformer should be checked at a frequent interval, and the leakage of the oil should be investigated. During my earlier slide, I said the moisture. If leakage is persistent, then there is always leakage of the air from the atmosphere to the transformer, and these leakages will hamper the life of the transformer. So one has to always attend these leakages, and leakage of the oil will be always loss of the oil. So whatever leakage is there, you have to top up those oils. So that is again the loss. So everybody has to be vigilant on the leakages. That's what the sample of the oil should be taken on the regular intervals and tested. So one has to take, see, sample testing is always a job where you have to spend the money. Sometimes people think that why to spend the money on the testing of the sample. But if you do the analysis of the sample, there is always tendency, we got the report, chalo, report is there in file, it is okay. But one has to interpret these reports, these values with the earlier values and collect the data, and on that basis of data, you can discuss with experts. You can really interpret those things into the life of the transformer. One can easily determine, or one can easily guess what will happen tomorrow with the transformer. So the reconditioning of the oil. Sometimes when you find that the oil properties are degrading as per the used oil specification, it is going near to that, then one can go for this filtration procedure where you can remove this acidity of the oil as well as insoluble impurities or a sludge formed during the during aging of the oil, dirt, dust, of course moisture. One can remove this vacuum filtration, and you can do up to certain extent reconditioning of this oil. In while transformer is on condition or an off condition, you can do all these things. Next slide. Apart from this maintenance, during this maintenance procedure, one has to look into the what type of the filters you are using. You are using clean filters. There is a Fuller's treatment is there. One can go for the Fuller's treatment for the to reduce the acidity form, because acidity, once acidity is formed in the transformer, it is going to increase. So one has to look into the commercial aspect of that, and accordingly to take the decision, one has to go for the Fuller's treatment or not. That is most important. If the VDV of the oil as per this goes something below 40 or 50 or a 40, one should think of the reconditioning oil. But before reconditioning, one has to check simultaneously moisture of the oil as well as the acidity of the oil. If moisture is high and acidity is low, one can go for the vacuum filtration, or acidity high, then one can go for the Fuller's treatment. If tan delta or power factor of the oil is increasing rapidly, exceeds below 0.01 to 0.2, the oil should be treated for the improvement to get the tan delta value less than 0.01. The procedures will be the similar. There are the certain pads available in the market. There are certain Fuller's, one can go for those treatments. Next slide. So all the tests which are carried out to be as per IS 1866 systematically and periodically as per the guidelines as a part of the maintenance schedule, and strictly should be interpreted with the past values, and to have the graphical representation how it is increasing. Those all things. So periodic testing will help O&M to build a data bank and to have the case studies for futuristic transformers also. When you can have the few new transformers, you can use this data to have the certain design changes or certain things you can modify in that. This data will be always helpful for everybody for this those things. Next slide. So about the oil storage, every oil manufacturer always gives the storage conditions on the drum in terms of size, where you have to mention that the drum should be stored placed horizontally with the opening cap, or at the middle or the top. It should not be the bottom. So there will be always leakage of the oil will not be there continuously. That is the reason. Then again, it has to be kept away from the ignition, or if possible, you can store it in a shaded area. That will be the one more option. It should not be stored in a rainy things. Means rain should not fall directly on the drums. That will be the beneficial. Or if you are storing in an open area, you can put certain tarpaulins on that in order to avoid the moisture increase. So before filling, one has to, you are definitely, we are performing well, before filling, one has to do the filtration, because when you are doing the filling, there is a tendency to increase the moisture, and when this moisture goes to the transformer directly, it is going to hamper the electrical properties, as well as that moisture will impart from the paper oil to the paper, and it will retain to the paper. So if you do the filtration before this, that will be the always helpful. Next slide. So these are the specifications for the oil, fresh oils, basically IS 335. There are the two types of the oil. Another last one is of the switchgear oils, so which are of the less volumes, but type 1 and type 2 transformers oils are there. And basically point number 18, that is inhibited oil, uninhibited oil. That is in uninhibited oil, where the detected limit, GHT limit should be less than 100 ppm. Or trace inhibited, there is a GHT limit is 800, less than 800 ppm. And inhibited oil normally less than 4000 ppm. One has to say this, and the rest of the tests are mentioned in this, that is the water content should be less than 30 ppm, but normally people use this something around 6 to 7 ppm during filling. We keep 5 to 7 ppm, so at the site it should be less, one should get less than the required specification. So next slide. So this is another continuation where most of the tests, like perfural content, initial fresh oil, you can see that it should be not detectable level, which I had discussed already. It should not be there, perfural, because perfural comes from the paper. Oxidation stability. This gives the impact or effect of the oxidation antioxidant. What is effect of the antioxidant? And during oxidation stability, one has to measure all the total acidity, sludge content, and power factor. So gassing tendency, flash point, and those are PCB content. PCB nowadays there are the no oil content of PCB, so they always give the not detectable limit. And polycyclic aromatics is also should be less than 3%. Next slide. I once again thank all the representatives from the various organizations to have to listen our seminars. I hope this will be improves your knowledge, increasing your knowledge. If you have any questions, you can go ahead. Thank you very much, everyone.
Dr. Milind, do you have to something add further, or should I go to question and answer session?
No, I think, thank you, Girish. I have nothing further to add, Rajivji, so we can.
Thank you. Thank you, Dr. Milind and Mr. Girish, for such a wonderful knowledge sharing and very in depth. We have some questions in the chat box. So can we take up these questions?
Of course.
Okay. So the first question is by Mr. Shashi Prasad, and Mr. Ame has answered it, but still if you want to add something, you are most welcome. Presentation says, question is, presentation says, biotransol cannot be used for breathable transformers. Transformers with air cells, COPS are also breathable transformers. Do you mean that biotransol cannot be used with transformer with air cell and COPS?
I am sorry, I am not able to see the chat box.
I have read the question. I will once again repeat. Presentation says that biotransol cannot be used for breathable transformers. Transformers with air cell or COPS are also breathable transformers. Do you mean that biotransol cannot be used with transformer with air cells or COPS?
So essentially, I think, like you said, Abhay must have answered the question. I can't read his answer, but essentially, wherever there is an ingress of oxygen or air into the transformer, if that is possible, then we cannot unfortunately use it because that would mean contact with air, and over a period of time, that would lead to oxidation.
Sir, I would like to add one more thing to this. Basically, if you are talking about the air cell type of arrangements, in air cell, I'm audible, sir?
Yeah, you're audible. You're audible.
Yeah. So when you are talking about the air cell, what air cell do is not allowing any outside air to go inside, and whatever inside air or inside atmosphere doesn't come in contact with the
Excuse me,
outside
Mr.
atmosphere.
Excuse me. There are some other people's mic is on. Request to keep it off.
Basically, hello, I am Amay Kulkarni from Savita.
Yeah.
Basically, breathing, sir, want to see breathable means free breathing system. What is the
Free breathing
standard
system
says?
only.
Yeah, correct. So it can be used with the seal breathing system where air cell is used in the conservator. So it can be very.
We are talking about the air cell. Air cell itself, the function of the air cell itself is to prevent outside air to go inside.
So here breathable. So in the presentation, the breathable means free breathing system.
Free breathing. One has to be the. We will be specific to the free breathing.
Exactly. So with the air cell, it can be very well used. No problem.
Okay, thank you. Thank you for your elaborations, Ame and Girish.
I hope this will cover the things. Yeah.
Yes. Then there is a question, one more question by Mr. Mohit Kumar, that what is the basic difference between type 1 and type 2 transformer oil and how to select? Further on that, how to correlate in between furan analysis and DP of paper? Is there any limits for furan or oil in service? Or furan
Basically, this type 1 and type 2 transformer oils, there is a difference in a viscosity. If you can see the IS 335, there is a viscosity at 40 degrees Celsius, you will have around 12 CST, and viscosity at 40 degrees Celsius for type 2 transformer limit is 15 CST. So basically there is a difference in a viscosity, there is a, you can say, most of the basically viscosity difference is one of the things. Second thing is a pour point difference. Since basically it is understood, low viscosity oil you will have the very good pour point, higher viscosity oil you will have the inferior pour point. That is 40 degrees Celsius is for the type 1 transformer, and 10 degrees Celsius is for the minus 10 degrees Celsius is for the type 2 transformer oils. So these are the difference. It depends on the transformer manufacturer which oil and which conditions they are preferring for the transformer. It is basically those things. So it is up to the transformer manufacturer which oil they prefers. Accordingly, every oil manufacturer will provide the oils on basis of pattern. So prior to oil, one has to go for these specifications and select the oils accordingly and discuss the terms and conditions for the same. And second question, I haven't heard. Can you repeat that?
It is about how to correlate in between furan analysis and DP of paper.
Yeah.
Limit for oil in service.
The equation is somewhat longer and it is exponential equation basically. If you go for certain literature, you will find that equation also. If at all, I can share that equation in my later mail, sir, with you. How you can correlate. It is basically, briefly one can say it is exponential determination basically.
Okay.
Exponentially one can calculate from the degree of polymerization to the life of the transformer.
Okay.
But generally, normally people say when the degree of polymerization falls below 250,
Hmm.
one can really think about the transformer for the replacement or go ahead for the paper changes if possible, I should say.
Yep. Yes. Thank you so much. There is another question from Mr. S.L. Mishra, that what is the cause of increased guessing tendency?
Pardon, sir? What is a?
Cause of increased guessing tendency.
Basically, gassing tendency is one of the most, say, confused and not cleared phenomena for the transformer oil industry as well as the transformer manufacture industry. So one has to understand the concept of the gassing tendency. Basically, gassing tendency is where the gases are absorbed by the aromaticity, the somewhat aromatic molecule present, and this aromatic molecule always has a tendency to absorb the gases from the oil. So
Okay.
this one measures this gassing tendency of the oil is measure of the absorption of the gases basically. So that is the thing that basically is there, that there is a absorption of the gases which gives an indication. What is the absorption of the gases? Basically, naphthenic oils somewhat have the good gassing tendency than the paraffinic oils.
Yeah.
It is a general term, say one can say, general industry terms.
And also, as can be seen in this slide, it also depends on the condition of the oil. So if there is sudden spurt of heat because of any reason like a hotspot or a thermal decomposition, for example, then it can lead to better or faster, not better is not the right word, but faster accumulation of some of the fault gases.
Okay. Okay. Thank you so much. And there is one more question by Mr. Mohit Kumar, that how to distinguish between stray gas and fault gas from DG results. How to distinguish between stray gases and fault gases from DG results.
Actually, DG analysis, there are the what we said is the stray gases and fault gases. The acetylene, ethylene, those all things you can consider as a fault gases. But the gases which are generated in the oil itself, because of that, these are called as the stray gases. You can say naturally dissolved in the oil. So that is basically, there are the two classifies, that is acetylene and acetylene and ethylene. These are the, you can say, fault gases. And the rest of the things, hydrogen and those all things, you can consider as a stray gases. Carbon dioxide, those all things as a stray gases.
Yeah. Okay. Any more questions from the audience? We got some offline questions, Dr. Milind, but most of them are covered in your presentation and Mr. Girish presentation. One question I would like to put up for you is that when we reclaim the oil, I mean, when the oil is deteriorated and it is being reclaimed, is there any voltage class limit, upper limit, to use reclaimed oil in transformers? I mean, how good is that oil as far as the voltage or electrical stress is concerned?
So ideally, it is very difficult to say because unless we test the property of the reclaimed oil, so there is no general rule by which we can say that reclaimed oil can be a blanket used for so and so class of transformer.
Yeah.
Once we find that the typical, so that's why there are two actually test standards for used in fresh oil. So typically what we say is that if it is meeting the parameters, then from say about 11 kV type of transformers, you can use reclaimed oil.
Okay, okay, that's very important. And one question has come in chat box from Ramesh Vora, that is there any specific time period to do filtration of oil to improve result? That is BDV, ppm, or any gases in the transformer.
So there are the certain guidelines on the IECA as well as IEEE, those C57 types. Guidelines are there for the in-use oil maintenance and those all things. You can go through those and accordingly set the values and parameters as per the classes.
Okay.
Because there are the different classes mentioned in that, and for those classes there are the different physico-chemical parameters given in the specification. You can go through those.
Okay.
If you do not have, you can ask for the those things. You will get it.
Sure. Thanks a lot.
Accordingly, you can get the things.
Thank you so much. Now, one last question, which is non-technical and little funny, but it is interesting that old or aged oil have any therapeutic property, because in villages you will find people taking the oil from the transformer and applying on their knees and joints, and they claim that it relieves their pain. So, do you have any information coming from the R&D of the Savita?
So, frankly, some time back we had this discussion in our lab. You will not believe it on this, and people do believe that yes, it has some therapeutic value. But to be very honest, as a scientist, if you ask me, let's be very clear. Any oil which has been used is classified categorically as an hazardous waste.
Hmm.
Is potentially harmful for human contact. So we would not recommend using any used oil for any human contact or any therapeutic value.
Okay, thank you so much. So, with this, we are coming to the end of today's program, and we have this our YouTube channel, which you can access anytime. And most of these webinars will be available on the YouTube channel. Of course, it depends upon the approval of the presenter and the company which they are representing. So, we try to put the all the programs on the YouTube, so you can watch anytime in future. And our next program, which is on the next Wednesday, is also going to be very interesting, about which the announcement will be doing mostly by tomorrow. And the program is about a very, very interesting topic, that is about building factor of CRGO, or lamination. So that is a lot depends upon building factor in transformer core designing, and as well as then limiting the no-load losses to the minimum possible. And the guest speaker would be Mr. Gaurav Bhatt. He is the expert in CRGO, and more details will be followed in our tomorrow's announcement on the program. So I'm once again thankful for all the people who took time and made it sure that they come and attend the program. A lot of preparation goes for these programs, and there is a team behind it, and they are working really very hard and sincerely. And when people come in the program, so the team feels very happy, and they feel rewarded when the program goes very fine. So thank you so much to all, and special thanks to Dr. Milind Vaidya, that he has took so much pain to prepare the presentation. I myself know the pain of making the presentation. A lot of studies required. When you put one slide, probably you have to do some work of at least 1.5 hours, and then you get one good slide. So I can really understand the efforts you have put on this. And I'm also thankful to Mr. Girish, that he has shared his experience and knowledge very freely with the audience. And I hope that the information which today is being shared in this platform by the team Savita would be very useful for the people, and it will be passed on to the people who could not attend the program with their respective organizations. If you have any further queries, if you have any further questions, you are free to WhatsApp me, call me, or send a mail. We will try our best to answer your questions on this program as well as past programs also. So with this, I would like to take leave of all of you, and thank you so much, and hope to see you in our next programs and making it successful. Thanks a lot.
Thank
Namaskar.
you.
Bye bye. Thank you, Dr. Milind. Thanks a lot.
Thank you. Bye.